Welcome to General Structures 2 and Lateral Forces, Lesson 4 quiz. Question number 4. It says that the vertical ground motions are usually neglected in earthquake design because, and let's see if I can figure this out, because usually the vertical forces are based on like live load and other type of loads, to where those maximum vertical forces aren't controlled by the earthquake. They're controlled by the they're controlled by other issues, I guess. And then the horizontal forces are much greater than the other forces that you're going to see. Most of the other horizontal forces or lateral forces are wind is your other big lateral force. Other than that, you know, off the top of my head, I don't even think of any. Usually wind is your other. And what you're going to design this typically the earthquake forces for is just to not kill anybody, in other words. The earthquake will not destroy, but it will damage the building. And that's okay as long as it doesn't have a catastrophic collapse. And you might have to repair a lot of things. You're going to have to repair a lot of your, especially your siding, or if you have stucco, it's going to crack the stucco, or the brick's going to be cracked. So you're going to have to do a lot of that fascia type systems need to be replaced. But for the most part, even your structural system might deflect. Like you might have something that it comes in and it might sag like that because this beam was overstressed and it went past its elastic. Once again, you have the elastic curve that goes up like this, and then goes over like that. This is your point elasticity, where if you go up to here and you let that, this is stress and strain. Sorry, that's not the best. There you go. And this is like, there you go, strain. If you put the stress up to this point, it will go back down. But if you stress it past this point, for instance, if you stress it to here, then when you release that stress, it ends up permanently deforming it this much. That's your permanent deformation. And therefore, this may have permanently deformed because of that overstress from the earthquake. But it did not see its ultimate stress, and therefore its breaking point. So you're good. All right, I hope that made sense. I'm going to move on and let's go ahead and answer these questions. Let's see what they have. All right, 1. An earthquake causes only that's not right. An earthquake causes only horizontal ground shaking. That's incorrect. You also get vertical stuff, vertical shaking as well. So that's definitely incorrect. So we go down here. 1 only is incorrect. 2. The vertical motions are generally smaller than the horizontal motions. Vertical motion is generally smaller. That could be correct. I'm no earthquake specialist, but that sounds like it's right. And if you actually go back and look in they have that. It says that the vertical motions are generally smaller than the horizontal motions. Most buildings have considerable excess strength in the vertical direction. That is correct. A lot of that excess strength from the live load and your additional dead loads and whatnot. But there's a lot of dead load that's not there. If you have a building, an office building, it's never going to see that actual live load that it's been designed for, because you're not seeing 75 pounds per square foot in 99% of that building. So. And that's why they reduce the live load, but even then, you have more considerable strength in the vertical direction. So we could be 2, 3, and 4, or definitely not C, because that doesn't include 3. Now let's look at this. Design live loads already include an earthquake factor, and that's incorrect. The live loads do not include an earthquake factor, but once again, the vertical direction, it usually has excess strength. But that's not what the live loads are based on. They have nothing to do with the earthquake. So we go down here. It's 2 and 3. It does not include 4, so therefore our answer is going to be D, 2 and 3. All right, I will see you on question number 5.